So now that we've explored the structure and functionality of the client, let's take a look at how to implement the client. And this, again, is going to be a pretty fast walkthrough because we've already talked about most of this stuff. I just want to show you the code version of everything as opposed to the slide version of everything, because we can trust the code. Slides sometimes have mistakes, but the code is the ground truth for what we're doing. As before, you can get this in the EX2 project in my WebFlux folder in my live lessons GitHub repository. So here we are now looking at the client side of the house. This is in the test project. You can see here we've got a couple different things we need to look at. We have the client for doing concurrent fluxes, and we'll take a look at the implementation here. This is very much mimicking what's going on the server side, except we're now moving this to the client side. So you can see that PC client concurrent flux has an auto-wired proxy. We're going to look at the proxy in a second. It takes a flux of prime candidates. It uses flatMap. And for each of the prime candidates in that flux of prime candidates, it will go ahead and make a call to the proxy to check if that is prime or not. And it subscribes this call to run on the bounded elastic scheduler, because this is going to run in the background. And we also want it to be able to work across a network connection. So it needs to be bounded elastic instead of parallel. Down here, test flux call, super simple. We just forward to the check if prime flux method, which is the proxy, and that'll just do all the processing on the server side rather than on the client side. Let's go take a look at the ParallelFlux version, very similar to the concurrent flux version. We have a proxy that's auto-wired. The main difference is that we take our flux of prime candidates, convert them to a ParallelFlux, run them in the bounded elastic scheduler, and then we basically make all the calls here running using the ParallelFlux, using the bounded elastic scheduler, very similar to what we do. And the reasons why we do it, very similar for the concurrent flux, because these are not blocking calls, these are IO calls. And then we convert the results back to a flux, and that's what gets passed back to the client. As with PC client concurrent flux, the test flux call is super duper simple. It just forwards to the server using the proxy to check if that flux of prime candidates contains primes or not. Here's the proxy API interface. You can see, once again, we define these two different proxy methods, adding in the various parameters that we need to put here. This is the funky stuff that we talked about before that enables a flux to be passed as a parameter. Otherwise, you can't do that. Otherwise, it gets confused. And the request body is also used in conjunction with the application ND JSON value in order to pass this in the body of an HTTP request. And I believe ND JSON stands for new line defined or delimited JSON. So it's basically this set of data elements that are separated by new lines. The other piece of the puzzle that's important here is the client beans method. And this is what's used to make the PC proxy API, which, as you can see, is what's auto-wired for both PC client concurrent flux and PC client ParallelFlux. And the client bean makes a PC proxy API instance. And it does this by first creating a web client, which is the WebFlux way of being able to invoke both synchronous and or asynchronous method invocations through the proxy mechanism. And we connect to the server through the base URL here. That gets us back a web client. And then we use something called an HTTP service proxy factory, which we adapt to the web client. And then we build an instance of this. And then we use it to create ourselves a new instance of the PC proxy API interface. And you just have to get used to this. Even though PC proxy API is an interface, it's described using a class file, class object, which is the metadata that's used to explain to the Java runtime how to manufacture an instance of one of these things. So this is actually going to be created, and we're going to see in the next part of this lesson how an instance of this is going to be ultimately used by the PrimeCheck test. This instance, of course, here is used to wire into the appropriate PC client ParallelFlux or PC client concurrent flux. So that's how those different pieces work.